Oh, Year 10. Page 6 is all about finding the gradient of straight lines. A skill that's really important because when you get onto maths later on, the gradient represents all sort of things like velocity, acceleration in certain contexts, and lots of different things in different contexts. So how do we find the gradient of a line? First off, what does gradient mean? Well, gradient means steepness. You might have seen the word itself on a road sign or something like that. It just means how steep is the line. And the way you work it out is to do the change in the y coordinates divided by the change in the x coordinates that caused them. Okay, or a shortened version I like to remember is rise over run. You want to pick 2 points on your line which are nice ones, so they go through a corner of a square, so it's easy to count from. For example, there would be a good one. I could just go 1 across here, and I can see that I've gone 2 up, and I'm at another nice point. So I've created a little right angle triangle there, and that will just give me my run, which is 1. So my run is how far across I've gone. And my rise there, for that run of 1, what was the rise? The rise was 2. And it's really important that you look at the numbers on the axes, not the number of squares, because the axes could be going up by different amounts. So once we've got those numbers, we do a little division. We do the rise divided by the run, always that way round. So 2 divided by 1 gives us a gradient of 2 for that graph. And I'll just show you that if you'd have chosen a different set of points, for example there, maybe you'd gone across 2 and gone up there, that we should get the same thing. So my run there was 2, I've gone 2 across, and my rise was 4. If I'd have used those numbers and done 4 divided by 2, I also would have got a gradient of 2. On part B, again, it doesn't matter where you choose as long as you give yourself nice points. You could go 1 across 1 up, you could go 2 across 2 up, etc. But importantly, whichever you choose, that division will always give you a gradient of 1. Okay, so 2 rise divided by run here would also give us a gradient of 1. Okay, I won't go through all of these. I'll just choose one more with a negative gradient. This is the only one, part F, which has a negative gradient. Now hopefully you know what I mean when I say negative. These are all rising as we go from left to right. This one is falling as we go from left to right. Exactly the same meaning of sort of positive and negative as scatter graph correlation as well. So these, if our points kind of went with these trends on a scatter graph, that would be positive correlation. If they fell, that would be negative correlation. The only difference when you're doing it, it doesn't necessarily matter too much which side of the line you do your triangle on, but I would always do it by doing the run first. So if here I'm going from left to right, always left to right on the run, but this time I'm dropping. Okay, and that's going to help me see that my run was positive. Oops. So my run there was 2, but my rise, if I still think of it a rise, then it's going to make me think of a negative number. That's not risen, that's fallen, so my rise is negative 4. And if I use those in a division, that rise, negative 4, divided by the run, which is positive 2, that will give me a gradient of negative 2, because I'm dividing a negative by a positive. Okay, pause the video here, I'll reveal the answers. There's the answers. On to the next question. Very similar question, just slightly harder gradients to find. So again, find yourself a nice point on the line. That looks like a good point to me. I've got to go 2 across before I can go up to find the next nice point. And if I record my run and my rise, so my run there was 2, my rise is 3. When I do that division, rise divided by run. Now I could do 3 divided by 2 and write 1.5, or I could just leave it as 3 over 2. That fraction is as good as a decimal, so don't have to change back into a decimal, but if you did, it would be 1.5. Leaving it as a fraction is particularly useful for gradients that are very small, less than 1. For example, this next one, there's a nice point. It's very hard to say. If I just went 1 across, it's very hard to say how far up the line has gone there. You know, what fraction of a square has it risen? So that's why we pick nice points where it goes to the corner of some squares. So there, if we've had to go 4 across for this line to go up 1. The run is 4, the rise is 1, Therefore, the rise divided by the run is 1/4. Okay, just keep it as a fraction, it's much easier. And you don't really want to turn like a gradient of a third to decimal, because it will give you a recurring decimal. So just leave it as a fraction. Okay, have a go at these yourself, and I'll reveal the answers in a moment. Okay, there are the answers to question 2. In question 3, we're not given the grid anymore, but we are given a diagram, and we're told 2 coordinates. And really, we don't even need the diagram, as we'll see in the next question, but we can still draw our triangle between these coordinates, seeing as we've been given them. Okay, so just try and draw a roughly horizontal and vertical lines. Now, what has my run been to get from an x-coordinate of 1 to an x-coordinate of 4? How far across has this line gone? Well, it's gone 3 across, and that's clearly been a rise. It's gone from 5, a y-coordinate of 5, up to a y-coordinate of 11, so that's a rise of 6. So I've got my rise divided by my run, which gives me 2, gradient of 2. Okay, and just do that for each question. We're just going to do a negative gradient one, so question E. I always do my left to right first, remember. Okay, now to get from -3 to 4, I've gone across 7. So the run is always positive for me. To go from a y-coordinate of 8, though, down to a y-coordinate of -6, that's a drop. That's a drop of 14, or a rise of -14, if you like. So my rise, -14, divided by my run, 7, that will give me a gradient of -2. Okay, pause the video here, have a go, and I'll reveal answers in a sec. There's the answers to question 3. Okay, on to question 4. Okay, on question 4, like I said, it's the same as the question above, but without the diagram at all. We can do exactly the same thing though. To get from this x-coordinate to this one, that's been a run of 2. We've gone across 2. And to get from this y-coordinate to this one, that has been a rise of 6. So we've got our rise divided by our run. It gives us a gradient of 3 in this question. Now, one thing you might want to use with these questions is this little formula here, if I just write it over here. So the rise and the run, that's what we know the gradient is equal to. Now the rise, we could just say the second y-coordinate take away the first y-coordinate, and you can see that, hopefully that'll give us 6. So let's say it's the second y-coordinate, take away the first y-coordinate, and the run, we can do exactly the same but with the x-coordinates. We say it's this second x-coordinate minus the first x-coordinate. So 3 minus 1 gives us 2. And it's important that we stick to doing it a certain way around, that we don't alter these and have 2 and a 1 there and a 1 and a 2 there. A lot of people are tempted to do that just to give themselves a positive answer, but don't do that. Hopefully I'll show you why in a sec. Okay, so let's use that on this next one. So if we call this x2 and y2, and this one x1 and y1. Okay, so if we do this minus this, 12 minus 0, divided by 3 minus 0, that's just 12 divided by 3, which is 4. Okay, so if I can find one that gives us a negative gradient, this one, I think. Yeah, okay. So again, I'm just going to stick to having this second bracket as my second set of coordinates. So I'm doing -2 take away 6. So this y coordinate take away this one. And I'm then going to divide that by 0, take away -8. So put that negative in as well next to the take away sign. Now the numerator there, -2 take away 6 would be -8. And 0 take away -8, hopefully you remember that will cause a plus, so that will be +8, and when I divide -8 by 8 I get -1. Okay, so if you just stick to doing it a certain way round and just remember your negative rules, you will be fine with this. Okay, I'm going to go through question 5 and 6 now. I'll pause the video and you can and I get the rest of these on question 4. Okay, so number 5, find the gradient of the line passing through the points 4a, negative a, and 6a, 5a. Now, we've got some algebra in there, but that's okay. Let's just try our method and see what happens. So the gradient is equal to y2 minus y1 over x2 minus x1. So I'm going to say that this one is y2, so I'm going to 5a, and I'm going to take away, whoops, wrong one, take away negative a. Okay, so remember that's going to cause something special in a second. And then I'm going to do 6a, my x-coordinates, take away 4a. So remember this is going to cause a plus, so that's going to be 6a on top. On the bottom, I'm going to have 2a. And what's going to happen here is that our algebra is going to cancel off. These two are going to cancel because they're common terms on the top and bottom, and 6 divided by 2 would give me a gradient of 3. And number 6, they've just reversed the question slightly. They've given us the gradient but removed one of the coordinates. So again, if you stick to this equation, it'll be nice and easy. So this is our y2, this thing that we're trying to find. So I'm going to call it C. I take away negative 2. That's what I would normally do to find my change in the y coordinates. And then I'm going to do 8 minus 5 to find the change in the x coordinates. This time I know that's going to give me an answer of 3. Okay, just going to tidy this up a bit. So I know that when I do take away a negative, that's going to cause a plus. So C plus 2. And I know this bottom number will be 3. 8 minus 5 is 3. And that gives me an answer of 3. Now that's an equation that's pretty easy to solve. So if we multiply both sides by 3, that will give me just C plus 2 on the left. And that will give me 9 on the right. And then if I take away 2 from both sides, then C must be 7. Okay, I'm going to pause the video here and you can finish off these ones and then check your answers. Okay, there's the remaining answers to question 4. Okay, last question. One thing that's become a bit more focus on since the GCSE has changed is relating things to their real life context and where they come in useful. And this is why we need to know how to work out the gradient, because it could represent something in a real life question. This graph is all about phone calls and their cost. So the y-axis represents the cost in pounds, and the x-axis represents the number of minutes that the phone call lasts. The graph gives the values of amount, money, for minutes from 0 to 5. So give an interpretation of the gradient of the graph. Well, it's really important that they've used this word interpretation, and that basically means a real life context of what the gradient is representing. Okay, so what does the gradient tell us about this question? Well, if that line was steeper, what would that mean about the cost? That means the cost would rise quicker for a given number of minutes. So the gradient here represents the cost per minute. And just as a kind of belt and braces way to make sure I get the marks in this question, I would work out what the gradient is as well. So let's give ourselves some nice points to use. There we go. So my run there is 2. I've gone across from 1 to 3, so that's a run of 2. And my rise is 3. The amount of money it's costing me has gone from 2 to 5, so 3. And therefore the gradient, rise over run, is 1.5. Now I would actually use a decimal in this case because that's £1.50. Okay, so it's calls cost £1.50 per minute. Okay. Part B, give an interpretation of the intercept of the graph on the y-axis. So what does this point tell us? Okay, well, what that tells us is that if a call lasts 0 minutes, so let's say you call somebody and it goes to an answer phone and you immediately hang up or whatever, it's still going to cost you some money. How much money? Well, it's halfway between 0 and 1, so it's going to cost you 50p. So the interpretation, it could be something like the fixed cost of the call, or the initial cost, doesn't matter how you word it, and the amount there is 50p. Okay.